Okay, so for this question, we're being asked to look at this pegboard game, and we're supposed to try to find our total number of paths to the bottom. So I said A has already been done in the video, that's what we're going to work out now, and then we're going to try and use A to sort of work out the probability. So I'm going to go through A here, and then you guys are going to do B, C, and D. Now once you've done B, C, and D, there's no need to do E, F, G, and H because, of course, these things are all symmetrical. You notice the bottom is the exact same. And whatever we get for A, H is going to be a mirror image of that. It will be all the same numbers, making the same approach. So once we do A, B, C, and D, we're really done because E, F, G, and H are going to be the same thing, just on the other side of the table. So I start up here with this idea of how many ways are there for the ball or the coin or whatever to fall into this spot. And there's only one way, right? It can be dropped from A. There's no previous way that this could go. Once it falls into the slot at A, it can either fall to the left or fall to the right. Now again, there's only one way that it can do this, right? In the case of the first one, it drops here and then moves there. So what we're going to do here is we can actually use this to fill out a fair bit of this right away. We know that there's only one way to go here or here or here, because if you imagine this, to get to this spot, it would have had to have fallen to the right, then to the right, then to the right, then to the right, then to the right. And there's only one way that it can do this, right? Because, of course, we've dropped the coin into slot A. So we can just continue this all the way down the picture, going this way. This is, of course, the easiest way to start. So we can see right away that there's only one possibility for making the $1,000 in this particular area by the coin falling in A and then falling to the right every single time all the way down here to get to 1,000. Now, what we do from here is we have to consider now what other options there are. And we're going to use Pascal's method to do this because Pascal says that if there's one way to get to this cell here with the 1, and one way to get to this cell here with the 1, then there must therefore be two ways to get to this spot, because I could fall right and then left, or I could fall left and then right. Now, to get down to this section, we copy the 2 again, because the only way to fall into this slot here is to have fallen already into this slot and then turn to the left. There's no other new way to do that, right? You could only have come from this area. So basically what we're going to do here is we're going to add up the numbers. So I'll put them in bold here just so we can hopefully show this a bit easier. Sorry. Bold this one. And we'll bold the one beside it. And what we're always doing in this question is we're just adding up the roots together, just like one of those roots to school kinds of questions. So here I have 2 ways to get here and 1 way to get here. I must therefore have 3 ways to get to this spot, which means I have 5 ways to get to this spot and 4 ways to get to this spot. Again, all I'm doing is I'm taking the 2 numbers above it and adding them together. When I get to the edge, because the edge only has one side that it can come from, I'm always just copying the number here. If there are 5 ways to get to this spot, there's only 5 ways to get to this spot, because there's 5 ways to get here, and then you fall down here. To keep adding these up, we get 9 and a 5. Here we get a 14, another 14, and a 6. Okay, so you're getting the idea here. It's kind of like Pascal's triangle, but you can see that it's not quite perfect because there's, the side is cut off, so they're not going to add up in quite the same manner. Just to keep going here, we'll get 14, and we get 28, and I will just, let's let's see here. We'll finish this row and then I'll pause it and just do the rest. So 20 and then 7. And what I'm going to do now is I'm just going to pause the video quickly while I go ahead and fill out the rest of these. All I'm going to do is just keep doing what I'm going to do. Basically, I'm going to take the two parents and I'm going to add them together to make the number that goes underneath it. So let me pause and finish that off and we'll pick back up in a second. Okay, so now you can see I've gone ahead and finished the rest of the table. Again, all I did was just make sure every time I took the two parents and added them together to make the next row, right? And you can see now at the bottom that if you drop the coin into slot A, there are 132 ways that you could land at 100. There are 297 ways that you could land at 500. 275 ways to land at 1,000. 154 ways to land at 0. Another 54 ways to land at 5,000. 11 ways to land at the other 0. And 1 way to land at the other 1,000. What we can now do is we can take these numbers along the bottom, and these represent our sort of probabilities, if you will, for how we can get to the end. So what we're going to do is we're going to go total outcomes, and then we're going to do, so just make a little room here. Okay, sorry. So total outcomes, and we're going to go to little a here. So we're going to add up all these numbers. So 132 plus 297 plus 275 plus 154 plus 54 plus 11 plus 1. So there are 924 possible outcomes from dropping the coin into slot A. Now, you know, an outcome, when I say outcome here, I guess what I should really say is total paths. Because, of course, an outcome, there's really only, 1, 2, 3, 4, 5 different outcomes, right? Either $100, $500, $1,000, $0, or $5,000. There's really only the outcomes are possible. There are 924 paths to get to those various outcomes, though. Now, what kind of things are we asked to do here? Determine the probability of obtaining 0 points for this starting path. Okay, so let's go ahead, the probability. So probability of winning 0. And let's see how we can figure that out. So what we're going to do here, the probability of winning 0, going to take all the ways, so number of ways to get 0, divided by number of ways, number of paths total. So let's say number of paths that lead to 0, divided by the number of paths total. Just do it like this. So for us, we could see that to get 0, there's 154 plus 11, which is 165 different ways of getting 0. So we're going to go 195. Sorry, the number of zeros I said was 165 divided by 924. And of course, when we do that, 165 divided by 924, we get P of 0 equals this value we just created. So 0.18. So there's an 18% chance if you were to drop the coin in slot A that you will end up with $0. Okay? So this is the kind of idea you want to do here. You want to go through these different questions. I'd like you to post your answers to the discussion area. And again, make sure you check work with another person so that you can be sure that, that it's right. And if you do have a question, post it to the Unit 2 questions forum.